Hello, this is the Rapta demo. As you can see here, we have a standard 6-foot workbench with an array of cameras over this particular workbench. We have some up top, some behind it, and even some on the side profile. We also have a human-machine interface, and this is how the operator and the supervisors interact with our software. The GPU is located in this Dell tower right down here. And of course, we also have other tools like hand scanners, torque wrenches, and even RFID badging in and out in order to actually operate this system. So now let me go to the software side. So now you can see the software, and this is the operator side. These particular jobs are what an operator would perform the task for. We're going to do this bottom right-hand corner PC one, so let me click on this. And on the far left, you now see the tree structure of the different steps I performed during this operation. The first one is actually doing a data capture, and let me bring in the software with a hand scanner. Now I see an OCR read for that sticker, and that just happened to be somebody who did the inspection of that board. At this point on step 3, there's a video work instruction on the left, and on the right is the live feed. You see my hand waving in it. It's going to replay this over and over again until the operator actually performs the task. And this happened to already be installed. So let me go on to the next step since that thermal pad is already present. And then it's going to do a QA dwell, look at it, and see if that was installed correctly. And it was. Here we go to another video work instruction. Let me install the memory module. Let me get this put into place, and let me defeat it on purpose and move on to the next step. So it did a QA dwell on the clip for the memory module, and you can see at the bottom it tells us that it's not clipped in. So it's trying to give you guidance in order to get to good. At this point, all I want to do is actually get it settled correctly, and it moves on. At this point, we're going to capture the serial number for that actual memory module. Again, we're going to do another video instruction of this daughter board. Let me install it, and then go on to the next step. Now we have an actual torque event. Let me actually install this bolt. And you're going to see I'm going to double clutch this on purpose and create a fault. So I intentionally double clutched it to show you that we can even see the rotational angle. And in this case, we should have hit 2,208 degrees of rotation. However, I double clutched it, hit 1426. So it's possible that there's been cross-threading for debris. It's either too short or I double clutched it. In this instance, I'm actually going to reject it so you can see what this looks like on the report and move on to the next step. Get this one in. And perform it correctly. So now you can see we have our digital traveler where we take photographic evidence of every single step performed. I have the assembly name as well as the description. I have the operator ID, and I even have the rev of this particular assembly, including the date time stamp. The pass rate is how often the operator had to interact with the software to get it to move forward. And in this instance, I had one failure where I had to reject it, and that's this particular torque operation here. All the other steps that passed on their own had 100% quality with a 98% confidence on the inference. The assembly time, it took me 2 minutes and 20 seconds, and unfortunately that's longer than the benchmark of 123, so I have a training opportunity in order to actually get faster with this particular operation. You can see here on the genealogy of what was captured from a data perspective, I've got part numbers and product keys, and of course this could be everything from work orders and your serialization of the parents and children for this particular product, and that way you have full understanding of what's in this particular PC. If I move down here, the first one that failed, you can see here is the incorrect torque angle. I have the correct torque, but the incorrect angle that I double clutched on, and I had to fail it, so we'll go in and resolve this. Then there's my data capture, and of course the OCR verification of that. Then the video instruction, and here it actually passed at 8% confidence that was installed correctly. Another video instruction, and this passed correctly. Then I captured the particular memory module, and of course that could be part number or serialization or whatever, and installed that daughter board, and it had one correct torque action. This digital traveler can also be PDF'd. So let me click on this. You can see all of these PDFs for every single operation that occurred is stored locally. Of course, you can actually go get all of this data via our published APIs. So now let's go over and show you how to actually produce a model that an operator would actually leverage.